All right, so let's talk about rational expressions. Just so you guys know, anytime that you see the word rational related to mathematics, we're talking about ratios. We're talking about things that can be written as fractions. So a rational expression is the quotient. It's the quotient of two polynomials, p divided by q, where q does not equal the zero polynomial. That was one of the biggest things that we had with fractions. You can do all kinds of things with fractions: add, subtract, multiply, divide. But you can't have a denominator that equals what? 0. If your denominator equals 0, then your expression is what? It's undefined. Okay? So I'm just going to give you some examples, and we're going to look at a couple of these guys in more detail. An example of a rational expression is something like 7 over 12. It's just a fraction. That's all that it is. Likewise, I can make a fraction look more complicated. If I have x plus 7 over x minus 8. Now we're starting to look at fractions that have variable expressions. How does that play into things? How do I simplify these? How do they work in terms of equations? Now, we don't see everything in the scope of this class. We just see the first few sections of this chapter, and then we see a lot more when you go into 0310. I could even give you this monster. Yep. That's pretty disgusting, right?
Yes.
Now, these are just examples. They could get uglier, they could get nicer, but these are just a few examples that we have of what it means to be a rational expression. You have one polynomial in the numerator and one in the denominator. Likewise here and here. Even 7 and 12 are, they're monomials. 7 and 12 are, so they are it's the quotient of two polynomials, and the denominator does not equal 0. Now, speaking of the denominator not being equal to 0, we need to talk about things called restricted values, because these guys are algebraic expressions, which means I could replace x with a number, right? But the thing is, I don't want to replace x with a number that's going to cause me problems. So we talk about things called restricted values. Talk about restricted values. And a restricted value is any replacement of the variable that makes the denominator equal 0. Okay. A restricted value is any replacement of the variable that makes the denominator equal 0. Why did we say we don't want the denominator to equal 0? It would make the whole expression undefined, so we don't want the denominator to equal 0. If I look at one of the guys I gave you as an example of a rational expression, and I examine it further, I have x plus 7 over x minus 8. Now, for the most part, I can plug in any value of x that I want to into this expression, and I'll get some number out of it. But I need to see if there's a number that would make my denominator equal 0. So when I look at this guy, I should be thinking about this. When will my denominator, x minus 8, equal 0? Because if I know what makes that guy equal 0, then I can avoid that value. 8? If I take this equation and solve this, I find out that x equals 8. This is my bad value. If I try to plug in 8 into the numerator, I get 15. That's not the problem. It's when I try to plug 8 into the denominator that I have an issue. Because what would my denominator become if I plug an 8 in here? If I plug in 8, 8 minus 8 is 0. My whole expression is undefined. It doesn't matter what your numerator is. But if your denominator becomes 0, your expression is undefined. Do you buy that? So this is what I call a restricted value. For this problem, this is my restricted value. Now, there's a connection that we have here between this and something that we see in a lot of other math classes, and that's the domain. Now, the domain is the set of all x values that I can use in an expression. Later on, we'll see this in terms of a relation or a function. We use this set builder notation like this, and I'm going to talk about what are the values that I can plug in. And I'll use this. I'll say, well, my domain is made up of all x's. I draw this vertical line, which means such that, and basically it says, okay, what are your conditions? What are the values of x that you can plug in? And for me, it's going to be easier not to say what I can plug in, but it's easier for me to say what I can't plug in. I can plug in all x's as long as what? As long as x does not equal 8. Right? So I can plug in anything I want to into that expression as long as x does not equal 8. Do you all agree with that? Okay. Well, what if I look at the other example that I have up here at the top? I want to take this guy right here, the x to the 171st plus 93 over 2x squared plus 7x plus 6. Let's see if we can talk about what his restricted values are. When I'm looking for restricted values, where am I going to look? I'm going to look in the denominator, right? So for me, my big question is, what makes this denominator equal 0? So I got to figure this out. If I take 2x squared plus 7x plus 6 equal to 0, can I figure out what would make that guy equal 0? Right. What's that three-word phrase that's going to help me figure out the solutions to that? The zero factor theorem. Number one, it's already said equal to 0, so that's good. Number two, I need to do what? Factor. Now, when I factor this guy, I look for a common factor first. Is there a common factor for all of this? 2 does not go into everything.
No, 1.
1 is a common factor, but if I take out 1, does that help anything? No. So this is a trinomial, and I expect it to factor into 2 binomial factors. I'll break down the 2x squared. There's only one way, and that's what? 2x and x. What do you know about your signs?
Positive.
You said positive. Just one positive, or what?
2.
Both of them will be positive, all right? Now you've got to break down your 6 so that the factors of 6, along with the factors of the 2x squared, when you do the inside and outside, you end up with 7x. What factors will you use?
2.
If I use 2 and 3, can I put the 2 with the 2?
No. 3.
I'd have to put the 2 here and the 3 here. Does that work out? This gives me 3x in the middle, 4x on the outside, so that's 7x altogether. But what are your solutions when I use the theorem? What does this guy give me? Not negative 3, but negative 3 halves. And what does the other guy give you? Negative 2. So what I'm saying here for my domain, actually, first of all, when I talk about my restricted values, these guys right here are my restricted values. So what I'm saying in this problem is that you can plug in any numbers that you want to into this expression. Plug in anything you want to. Have a great time with this. However, what?
Don't use this too.
Don't use these guys. It's like when you go to a dinner party, whether it's with just your friends or your family, but you know there's certain topics that you're not supposed to talk about. You find out ahead of time, wait, what was the name of that uncle that's in jail? Oh, Bobby. Okay, so I need to make sure I don't bring up his name. You learn it so you don't use it, right? Just like when you take a foreign language class, what's some of the first words they teach you?
Hello, good morning. How are you doing?
Aside from hello, good morning, they also teach all the swear words so that you don't accidentally, well, sometimes, that's what I've heard, so that you don't, and so that you don't accidentally say them or misuse something, right? Or maybe that's just me.
I learned them on my own. No class will teach me
I like how my kids just like mistakenly learn bad words. So I was trying to say shirt one day, and he was kind of missing. I was like, dude, shirt has an R. He goes, oh, did I say? It's like, yeah. So I was like, oh, so it's supposed to be with an R, and so shirt. There you go.
I remember when I did German, they would never teach us how to. My teacher wouldn't teach us how to say bad words just because she thought it was bad.
Yeah.
This is a more
So
advanced
X,
thing,
our domain, is the set of all X such that what? What are the restrictions on X? What do we not talk about in this problem?
Negative 3/2 and negative 2.
So X cannot equal negative 3/2,
What if you can say by looking at the following?
and X cannot equal negative 2. Sorry?
Like, you could just look at the problem and say not to use 2. I could,
No, you can't.
like the,
You can just look at it and say, don't use 2.
yeah, because of the 2x squared. I will say so.
I don't think that's necessarily going to be true.
Not
And it's
necessarily.
not that I'm not using 2, I'm not using negative 2.